Okay, well, thanks for sticking in for our final presentation. I'm going to introduce Sergio B. He's going to talk to us about some promising pilot plant results concerning 3-MCPDE esters and other problematic chemicals that we have to deal with in refining.
Yes, thank you very much, Michael. Hi, everyone. So, most of you have used actually this product before, but we often do not think about where it is being made and how it's actually being made. I'm talking about the cell phone. No, I'm just kidding. I'm talking about vegetable oils and fats. Um, so recently, there is a certain chemical compounds that has been introduced to us, the scientists, and they turn to be quite harmful. Rats and mice can develop cancer when they got introduced to these compounds, and these compounds are called 3-MCPD esters and glycidyl esters. 3-MCPD stands for 3-monochloropropanediol. And on top of that, recently in Europe, there is a maximum limits implemented for both of the compounds. So oil refineries all over the world have actually now they have the task to come up with a refining method in which they still can produce qualitatively good oil, but they should have reduced the levels of these contaminants. So in terms of oil refining is actually a process in which you take crude vegetable oils and you treat it in such a way that you can remove certain unpleasant odor or color that you do not want to have in your oil, or like even like very bad taste. Um, Here, I have actually brought a sample with me. Here is crude palm oil, which is orange. It have a really unpleasant smell, and the next to it, it is the refined oil that was refined using our method that I'm going to talk to you in a minute. So these processing contaminants, they have different molecular structures, but they are also formed differently. So for example, 3-MCPD esters is chlorine dependent, which means that if you have a lot of chlorine in it, then you can potentially form a lot of 3-MCPD esters in your end product. And for glycidal esters is actually temperature dependent. So if you increase the oil temperature during processing way too high or process it too long at too high temperature, then you can actually increase this concentration of the glycidal esters. So for the industry, it is very beneficial if they would have method in which they can reduce these two process contaminants at the same time, because then it saves them money and time. So basically, we are looking for a one for all method. So here on the right, you can see our method that we have used for this chemical refining. And you started to use 100 kilograms of crude palm oil in our pilot plant, which we treated with citric acid to remove the gums and then neutralize the acids with sodium hydroxide. Afterwards, we wash it with water to remove the formed soaps, free fatty acids, but also certain salts and minerals, for example, sodium chloride. And with that, you also remove the chloride, one of the building blocks for example, the 3-MCPD esters. Afterwards, we bleach the oil with, for example, activated carbon and bleaching earth, followed up by a heat treatment, and you have your refined oil. So the key difference is these two steps here, the neutralization of the oil and the water washing. That is different from what is commonly currently being used in the industry, which is the physical refining. So with this method, we actually are able to reduce our glycidal esters concentration by a 73%, which you can see here in the gray bulk. And the 3-MCPD esters was reduced by 49%, which is the orange bulk over here. This is, of course, when being compared to our control, which is an unmodified physical refining method. So I think with this, we and the and the future of the oil industry can look brighter, basically, and we are able to produce oils that are slightly less harmful to us people. And with this, I want to thank you all for your attention, and I'm happy to answer some questions.
Thank you for that presentation. I don't see any questions from the community, so I'm going to go ahead and open it up to the judges.
Thanks so much for this, Sergio. I think you explained this very well, but I've heard of this process before, and I'm not quite sure what you'd say is really new about what you're doing. I mean, people have talked about neutralizing palm oil, but they said, well, the losses are too great to make it feasible. And buying enough centrifuges to do it for all the palm oil refineries in Malaysia or wherever they are is also very difficult. So how do you get round these objections, if you I mean, the losses are the real big one, I think, in this process.
Thank you for the question, Alan. I think I have to agree with you on that part. Chemical oil refining is indeed known for its relatively high oil losses. However, we are currently now facing uh, an actual health risk, and on top of that, the European Commission have stated the maximum limits. So basically, as of January 2021, all oil refineries have to come up with a method to reduce 3-MCPDE esters, which was lately added to the legislation.
Mm-hmm.
And I think there is how do you call it? I have recently read a paper coming from Malaysia, in which they have also tried to use this washing and neutralization method on a really large scale, and we are speaking here of 100 tons of oil or more. So it might be costly, but I think because of the health risk, we have to currently just take that into our account and put that on in our agenda for future research to actually try to minimize the losses while using, for example, a chemical refining method like ours.
Yeah, have you experimented though with sort of light caustic washing? I mean, this is something I've certainly heard of being done where you treat it's not as effective as chemical refining, I don't think, but if you get some slightly alkaline water and wash the I think there was a presentation by Sime Darby earlier in the week about this, washing the oil and using that to reduce the chlorine level and avoiding 3-MCPDs that way.
I have not experimented with that method before. And unfortunately, I was not able to attend the presentation of Simon Darby earlier this week. But to me, it sounds fairly plausible because I think it's key to reduce the formation of 3-MCPDE esters that you take or you remove one of the building blocks, which is fairly speaking the chlorine, whether it is coming from sodium chloride or from HCl, or like for example potassium chloride. The plants just takes it up, and if you press the palm fruit, it will be present in the oil eventually.
It's a nice segue into a question from the community about, Alan referenced this technology has been talked about before. There's some technical questions. I know plenty of people that would like to sell all those centrifuges. But a question, let's think outside of the scientific literature. Have you looked across patents? Have you looked across, any communications from companies in this space to see if there's methods for addressing this? Maybe the kind of the more mild caustic washing instead of true refining.
Well, I have to be honest with you that the recent literature uh, did not really state this. At least the one that I've read and the ones that I have found so far have not address this issue with mild caustic washing, for example. So I'm really happy if I can read upon the literature just to enlighten me further with this research.
Yeah, might be. I learned, had a great mentor early in my career that helped me. Like, if you ever want to check the patent stuff, just check the U.S. Patent and Trade Office. It's a really nice place to go and see what else is out there besides the chemistry literature.
I think there's a lot of processors experimenting in this field and keeping it to themselves.
Yeah,
they're not publishing papers about it.
Yeah,
which is
I feel
unfortunate,
like
I think.
Yeah, I feel like that's common in the processing industry. Do you feel that way, Alan and Irain?
Well, particularly in this field, but there's a lot of stuff going on in, and always has done in industry that people aren't writing about.
Yep. Sergio, I think what you have to do is just gain the trust of people that have deodorizers and just then spend time in their plant. But no, quick aside, because we got to have a little humor on a Friday afternoon. My mentor used to go to a cottonseed plant in Arizona, and they had a black box room that he could not go into. And it was an expander. That's all it was. It was an expander.
Okay.
So it is a very secretive industry.
I greatly enjoyed your presentation method there, Sergio. I enjoyed the levity you added to it. That kept good flow to it, and I could tell that you're very passionate about what you're researching. So very much enjoyed that. A brief question. It seemed as though you compared the results that you had to a physically refined oil. Could you say, was that physically refined oil just with just a physical pretreatment, no raise in temperature to form the glycidyl esters?
So the control that we used is indeed a physical refining method, and it contains a degumming step, which we use to remove the gums. We use citric acid for that, so that is similar to what we are using currently with the chemical refining method. The other thing that is similar as well is the bleaching step. There we use also activated carbon, we use bleaching earth, and we use a filter aid to help bind those particulates together. And then the heat treatment is done in the deodorization, and we use a temperature of around 260 265 degrees Celsius for that.
Okay, and in both the control and your experimental version?
Only in the control, because in the control, as with physical refining, you are actually removing the free fatty acids during the deodorization part. So you require a lot more temperature to get rid of those free fatty acids and the color and on the unwanted compounds. But in chemical refining, you already get rid of the most of the free fatty acids by adding the sodium hydroxide, because you can turn the free fatty acids into soaps. So the deodorization part in the end does not require that high of a temperature anymore.
Yeah, I think that's fair.
And I think that's the key also, in which we can combine the reduction of the glycidyl esters with the reduction of the 3-MCPDE esters at the same time. It's just
the neutralizing itself doesn't remove glycidyl esters. It's the low temperature of deodorizing that does it.
Exactly. Yes.
Preventing that formation, right? Perfect. And I guess I guess it's a tricky way to say it. Did you compare the losses in these various processes, as well as, I suppose, as they were talking about the different concentrations of the caustic? I guess maybe this is for future studies. It'd be interesting to see how varying levels of caustic addition affected that loss.
Indeed. Unfortunately, we were not able during the current experiments that we are running to actually compare the losses of the oil, but it is on our to-do list, and we are highly aware of the issue.
Thank you, Sergio.
Thank you.
I have one question, if I may. Interesting talk. When you're showing the graph where you start deodorizing, over the course of 10, 20, 60, whatever minutes. You say start of DOE. So what exactly does it mean? Like, what is it referring to? Certain time point of to start your deodorization process? How many minutes after?
So the graph that I've included in the poster show several sampling moments during the entire refining stage. So basically CPO is when the oil is still cold. Post degumming is when the sample has been taken after the degumming process, for example. And the start DEO is we took a sample after the oil has been heated up to the desired deodorization temperature. So at that moment, we also start the timer for our 60 minutes of deodorization period.
Okay. Yeah, I was just curious because if you see, some of the bars in the graph just stay constant right from the start of the DOE. So I was wondering if it is right away or is it, minute or two after you started, that was my question.
So it was at, let's say, T0 of the deodorization.
Okay, thank you.
Yes, you're welcome.